At 07:45 a.m. on February 21, 1945, Electrician's mate second-class Joseph Joe Kissel was doing something that, on paper, he had absolutely no business doing. He was inside a combat tank. Not just any tank, but an M4A3 Sherman he had personally helped cut open, gut, replumb, and rewire in a machine shop on Oahu. A tank whose 75mm gun had been ripped out to make way for a flamethrower system that he and a handful of Seabees and Army chemical warfare types had essentially invented from scratch. He was not a tanker. He was a Navy electrician, a Seabee from the 117th Naval Construction Battalion. The kind of man the Navy normally kept on bases and in back areas, stringing wire, fixing generators, building things the Marines then used at the sharp end. Now he was sitting in the assistant driver's seat of a Sherman on Iwo Jima, bumping forward at 8 miles an hour over soft volcanic ash toward a Japanese pillbox that had resisted everything the Marines had thrown at it for 2 days. On the other side of 20 feet of black sand and shattered rock, concealed in gray concrete and dark basalt, a Type 92 heavy machine gun chattered from a narrow embrasure. That gun had already killed at least 11 Marines that morning. 15 by the time someone got the numbers straight. There were 2 hard facts in Kissel's head as the tank shuddered under him. First, portable flamethrower operators on Iwo Jima were dying at a 90+% casualty rate. Not wounded. Not rotating out with combat fatigue. Dead. Second, the system he was about to fire was the only serious alternative anyone had managed to build in time. If his wiring failed, if the pressure dropped, if the igniters misfired, if a valve jammed at the wrong moment, this fire tank could die in front of that pillbox, just as spectacularly as any Marine with a tank on his back. He glanced at the gauges. He'd mounted himself. Fuel pressure, 300 pounds per square inch. Good. Propellant nitrogen tanks in the green. Check. Behind the armored bulkhead in the space where a 75mm gun breech and its ammunition racks once sat, 290 gallons of thickened fuel sloshed in welded steel tanks. Gasoline mixed with napalm powder as sticky as hot tar when it burned, as thin as kerosene under pressure. He could feel the driver's movements through the hull. Small corrections as the tank eased around shell holes and broken rock. Treads grinding, differential whining. Mortar rounds came in somewhere off to the right, their flat cracking detonations distinct from the high-pitched rasp of machine gun fire ahead. Kissel adjusted his periscope and brought the pillbox into view. It was almost invisible, just a darker rectangle in the jagged slope, a horizontal firing slit cut into gray concrete. The Type 92's barrel jutted from it, spitting an almost continuous stream of tracers across the ash plain at anything that moved. For 48 hours, the 4th Marine Division had been trying to neutralize that gun with mortars, artillery, and infantry rushes. Every time, the Japanese had simply buttoned up, waited out the barrage, then resumed firing as soon as the dust settled and the Marines moved again. The manuals said a flame burst could change that equation. The manuals hadn't included a section for designer decides to ride his own weapon into battle. That was all Kissel. He put his hand on the firing control he'd wired 3 months before at Schofield Barracks and waited for the driver to stop. If he got this wrong, if something he'd tested in the clean shops of Oahu didn't work here on Iwo Jima, men would die in front of him for the same reason they'd been dying for days. Bad math. He intended to change that. The math on Iwo Jima was brutal. 2 days earlier, on February 19, 1945, 70,000 Marines had hit black volcanic beaches at the south end of the island. Iwo was roughly 8 square miles of badly broken ground, terraced ridges, jagged ravines, caves and cuttings carved into sulfurous rock, all dominated by Mount Suribachi at the south, and a plateau of airfields and high ground to the north. On paper, the preparatory bombardment was devastating. 3 days of naval gunfire. over 2,300 tons of bombs, dozens of heavy cruisers and battleships blasting away. In reality, most of those shells had done almost nothing that counted. The Japanese, under Lieutenant General Tadamichi Kuribayashi, had spent months turning the island into a honeycombed fortress, 11 miles of tunnels, 750 major defensive positions, pillboxes, casemates, blockhouses, steel doors, reinforced caves, many with multiple firing ports and interlocking arcs. Naval shells had pounded the surface and collapsed some positions, but most of the key strong points sat back under the rock, behind feet of concrete and volcanic tuff. Artillery rounds from ships and field guns either bounced off or chipped at the exterior. What did work? What had always worked on places like Tarawa, Saipan, and Tinian was flame. At Tarawa, portable flamethrowers had burned bunkers that no number of riflemen or sand-choked 75s could scratch. At Saipan, men with tanks strapped to their backs had walked up to embrasures and hosed liquid fire into them, killing entire garrisons. But on Iwo Jima, the defenders had studied every one of those battles. They knew what flamethrowers looked like. They knew the shape of the tanks, the way a man carrying one moved. They had orders to prioritize them. A portable flamethrower operator on Iwo was carrying around 100 pounds of hardware and fuel. He got maybe 7 seconds of actual flame time from a full load. 7 seconds, usually in 1 or 2 second bursts, because any longer and he cooked himself. He also had a life expectancy measured, if you believed the casualty studies coming back from the first days of the fighting, in minutes. 92% casualties among portable flamethrower operators. If you strapped 2 cylinders and a hose to your back on Iwo Jima and walked toward a pillbox, you did it knowing that the odds said you would not walk away. A Marine division on the ground could keep doing that math, send one man with a flamethrower to burn out each bunker, lose him, then send another for the next position, or they could hope someone, somewhere, had found another way. Back in Hawaii in 1944, a few men had decided to stop hoping and start welding. Schofield Barracks on Oahu did not look like an incubator for one of the most feared bunker-killing weapons of the Pacific War. It was an army post, red-roofed barracks, parade grounds, motor pools, and, tucked away in one corner, a set of shops and sheds where the U.S. Army Chemical Warfare Service had set up what amounted to a garage project with deadly stakes. The man nominally in charge was Colonel George Unmacht, Unmacht, in the garbled way the story was told later, an officer who understood 2 things better than most: chemical weapons and the glaring mismatch between portable flamethrowers and modern fortified defenses. By May 1944, Unmacht had a problem set and a small hand-picked solution. The problem: how do you deliver large volumes of flame against hardened positions without making the operator a walking priority target? The answer, at least at the concept stage, was obvious. Put the flamethrower on a tank. The devil, as always, lived in the details. The Chemical Warfare Service had already experimented with flame tanks. On Saipan and Tinian, M3 light tanks, the old Stuart, deep and fitted with Canadian Ronson flame units in the bow hull position. Marines who saw them in action nicknamed them Satans. They worked, up to a point. A burst of flame could clean out a trench line or bunker that had shrugged off high explosive. But the light M3's thin armor and short range limited their use, and their fuel capacity meant they had to withdraw to resupply after only a handful of engagements. For Iwo Jima, Unmacht wanted something better. He found a pool of talent in a place the average Marine would not have thought to look. The Navy's construction battalions, Seabees, were full of men who had built and wired things in civilian life, then done it again under fire from Guadalcanal onward. Welders, pipefitters, electricians, machinists. Men who knew how to make big machines do exactly what they wanted, even if the manuals disagreed. 25 of those Seabees, all from the 117th Naval Construction Battalion, were quietly pulled from their usual duties and sent to Schofield. Among them was a 24-year-old electrician's mate, second class, named Joseph Kissel. He had shipped out originally as a lineman and generator tech. He arrived at Schofield to find himself in a Frankenstein's lab for armored vehicles. Alongside him were Army chemical specialists who knew portable flamethrowers inside and out, and Marine tank crews who knew every strengthening rib and weak spot on the M4 Sherman. Together, the three groups were given a clear mandate. Take the flamethrowers that were getting their operators killed and mount them on tanks that could survive where the men could not. The initial iterations were ugly. Unmacht's shop got their hands on Canadian Ronson units, standard Army M1 and M2 flamethrowers, miscellaneous valves, pumps, and cylinders scrounged from depots across Oahu. They tried bolting existing units onto hulls. They tried plumbing portable flamethrowers into tank auxiliary systems. Nothing quite worked. The ranges were too short, the pressures inconsistent, the mazis, ignition systems unreliable, melted wires and leaks everywhere. What came out of that frustration was the decision to stop thinking in terms of bolting a flamethrower on a tank and start thinking in terms of building a dedicated flame system that just happened to live inside one. 8 M4A3 Sherman mediums were allocated to the project. They were late production gasoline-engined tanks with wet ammunition stowage and 4 GAA V8s, fresh from the States. Good armor for their day, plenty of space inside, and, perhaps most importantly, a gun mount that could be repurposed. Under the guidance of machinists mate First Class A. Richa and a handful of senior Seabees, the 117th men stripped the Shermans. The 75mm main guns came out of their mantlets, associated recoil cylinders, elevating racks, and ammunition racks followed. Space freed by the removal of some hull 30 cal positions and ammo bins was opened up. Into that space went fuel tanks, welded cylinders and boxes that could hold around 290 gallons of thickened flame fuel, plus nitrogen cylinders to pressurize it. On top of that went the heart of the thing, the projector and its plumbing. The unit that emerged was known in shop shorthand as the CBH-1. CB for Construction Battalion, H for Hawaii, and 1 for the first of its kind. It combined elements from 3 different flame systems, a redesigned Ronson-type pump, modified portable flamethrower nozzles, and unique plumbing and valving to handle the increased volume and pressure. Where the 75mm barrel had once protruded from the turret, they mounted a flame projector that, at a glance, still looked like a gun tube. Inside, though, the bore was sized for a high-velocity stream of fuel, not a shell. The mantlet was reworked to allow about 270 degrees of traverse for the turret and useful elevation and depression for the projector, enough to rake trench lines or reach up to cave mouths. On the electrical side, everything had to be absolutely reliable. Standard portable flamethrowers used simple ignition systems, pyrotechnic cartridges, wiring that only had to hold up for the life of the unit, manual valves. A tank-mounted system would be asked to fire dozens of bursts over multiple days in dust, vibration, heat, and combat abuse. The ignition solution was part mechanical, part electrical. A waterproofed cylinder holding a ring of matches or igniters, rotating like the cylinder of a revolver. Each time the operator hit the firing control, the cylinder advanced to present a fresh igniter into the stream at the nozzle, tripped by an electrical impulse. If that circuit failed, all the fuel in the world wouldn't help. They'd just be spraying raw napalm that might or might not light when it hit something. That was where men like Kissel came in. While welders went through 150 pounds of rod per tank, and machinists cut brackets and flanges, Joe Kissel and a few other electricians crawled through all 8 Shermans, pulling wire, crimping connectors, mounting switches and relays. Each CBH-1 installation needed around 1,000 individual electrical connections. Some were simple, tie-ins to the tank's main power bus. Others required new circuits, separate from the vulnerable systems that powered radios or turret motors. Kissel treated each one like it was a man's life. He ran his own continuity tests on every run, then had another electrician check them again. He designed redundant grounds where he could. He learned, through trial and error, which connectors handled vibration and moisture better, and which ones failed after a few hot-cold cycles. By the time the 8th tank rolled out of the Schofield shop in late November 1944, he had somewhere around 1,200 man-hours into the electrical side alone. The result, on paper, was a weapon with impressive numbers. Operating pressure around 300 psi. Fuel capacity of NOS, early 300 gallons. Effective flame range of about 400 feet, more than the length of a football field. Roughly 270 degrees of turret traverse and a useful arc of elevation. The Army paperwork called the finished system the POA CWS-H1, Pacific Ocean Areas, Chemical Warfare Service, Hawaii, Model 1. The tanks themselves officially were M4A3 R5s. Marines who watched them test fire in training areas on Oahu, gouts of flame reaching out across open fields, came up with a simpler name, Zippos. In tests, the Zippos performed beautifully. On Schofield's ranges and at other Hawaiian training sites, they rolled up to mock pillboxes and cave entrances, belching sheets of fire that clung to concrete and rock. The CB-H1's ignition system worked like a charm under controlled conditions. Bursts could be modulated, short licks to threaten, longer blasts to engulf. Still, field tests weren't combat. Things break under fire that never break on a range. Tanks throw tracks in real craters, not just dirt mounds. Rockets land where blueprints never anticipated shrapnel paths. Men panic. Circuits that were perfect in a clean shop fail when dust and sweat and salt water get into connector blocks. The Navy and Marine Corps recognized this. When they scheduled the 8 flame tanks to ship out with the assault echelons for Iwo Jima, they didn't just send the hardware. They sent the men who had built it. Electrician's mate 2nd Class Joe Kissel and shipfitter 1st Class J.T. Patterson, along with a few other key Seabees, were ordered to accompany the M4A3 R5s to the forward area. Officially, they were there to provide technical support and maintenance. Realistically, that meant Hawaii to Iwo, and it meant maintenance under fire. Kissel understood exactly what that implied. No one on Earth knew the Zippos better than the handful of men who had taken them from sketches to welded steel. Marine tank crews scheduled to operate them had been given a crash course in the controls, the pressure systems, the quirks of the igniters, but they had had only a few weeks of live practice. In a perfect world, those crews would have had months to beat the systems up, breaking and fixing them until the Seabees' names were just footnotes in the maintenance logs. Iwo Jima was not a perfect world. If something broke in combat, Marines would not be able to wait for a factory rep. Someone, possibly under fire, would have to climb onto or into a tank full of napalm to patch a leaking valve or hot wire a bad relay. Someone would have to crawl down under the turret to clear a jam in the match cylinder. Kissel didn't like the idea of sitting on a ship or in a rear depot giving phone advice while Marines he'd trained with died 20 yards in front of a bunker, because a wire he'd crimped months earlier finally let go. When the Zippos rolled down LST ramps onto the black beaches at Iwo on D-Day, he went ashore with them. For the first 2 days, those 8 tanks did mostly what every other tank on Iwo did. They sat pinned down, bogged in, or shelled mercilessly. The beaches were a nightmare for armor. The volcanic ash was like dry coffee grounds, so fine and deep that tracks churned without getting purchase, throwing roosters of black grit. Tanks dug in, belly plates settling on unseen ledges, track tensions straining. Japanese gunners had pre-sighted the approaches with artillery and mortars. Anti-tank guns hidden in caves and pillboxes waited for silhouettes. Marine commanders, already overwhelmed by the chaos of getting infantry, guns, and supplies off the beaches and onto the first ridges, were understandably cautious about pushing their special wep, Schuans into that meat grinder. 8 flame tanks were a valuable asset. Lose them to an unseen 47mm AT gun in the first 24 hours, and Iwo Jima would go back to being a place where men in green walked up to concrete bunkers with 80-pound backpacks of fuel and 35-pound guns, and died. So the Zippos stayed mostly out of the direct line those first 2 days. Tank crews and Seabees dug them in just beyond the surf line. Patterson and Kissel checked fuel lines, bled air from the nitrogen systems, and double-checked every circuit they could reach without pulling entire panels. Word of the new tanks spread among infantry officers, half rumor and half wishful thinking. Men hunkered down behind low sand ridges, watching tracers rake the beaches and hearing stories filter back. They've got tank flamethrowers here now, like Satan tanks, but bigger. They're going to burn those pillboxes out. On the morning of February 21st, D+2, one battalion commander decided rumor and caution weren't going to clear a particular problem burning holes in his line. On a sector of the front held by the 4th Marine Division, a reinforced pillbox dug into a rise of rock and ash had become a focal point. The position was well placed. From its firing slit, the Japanese heavy machine gun crew inside had clear fields of fire across 200 yards of open, gently rising ground. Anyone moving across that stretch, rifleman, machine gun team, corpsman, was exposed for long seconds. Over 2 days of fighting, at least 15 Marines had died trying to close with it. Mortars and artillery had bracketed it. Tank guns had slammed armor-piercing and high-explosive rounds against its external concrete. Each time, the Japanese hunkered down inside. The structural design of the pillbox gave them a buffer. The firing slit was just that, a narrow aperture. Behind it, the machine gun. S position sat deeper in, with blast walls and offsets. Shells that struck above or to the sides did little more than chip the outer layer. The Marines had learned the same lesson from other bunkers on the island. Nothing less than fuel and fire poured directly into the interior would kill the men inside. But anyone trying to get close enough with a backpack flamethrower had to cross that 200-yard lane. So far, no one had made it closer than 70 yards before being cut down. By mid-morning on the 21st, after yet another failed infantry rush, the division had had enough. A call went out. Flame tank requested for fortified position at grid such and such. One of the 8 Zippos was assigned. As the crew prepared to move out, Joe Kissel made a decision. Officially, as a Navy electrician attached to the flame tanks for maintenance, his place was behind the lines, at the rally points, waiting to see what broke and where. Unofficially, everyone involved understood that if the CBH-1 choked at the wrong moment, Marines would die. Kissel looked at the tank he'd spent months crawling through and wiring. He knew every line, every connector, every fuse and switch. He knew where he could bypass a failed relay, where he could jump power from the tank's bus to the ignition cylinder, how to coax one last burst from a struggling pressure pump. He also knew that once that Sherman left the relative safety of the assembly area and rumbled toward the Japanese lines, there would be no time to call for a tech bullet or send a runner back to fetch the electrician. So he climbed in. The Marines called him Kell, mangling his name the way Marines often did with Navy ranks and unfamiliar syllables. To them, he was just another body inside the tank, sitting in the assistant driver's spot, hands near the flame controls. To Kissel, it was something else. He had built this weapon down to the last solder lug. If it was going to be used to kill men and save others, he was not going to observe that reality from a neat distance. The driver eased the Sherman forward out of its scraped-out hull defilade and onto more exposed ground. Under the tracks, the volcanic ash compressed slightly, then began to churn. The tank's weight, 30 tons or so, found enough traction to keep momentum, but every little rise and depression made the hull pitch. Inside, the noise was a mix of things: the roar and whine of the Ford V8, the clatter of treads as they picked up and dropped grit, the creak of the turret basket, the faint clunk of tools hanging from interior racks, From outside came the sharper punctuation of battle. Mortar blasts, intermittent rifle and machine gun fire, the crack and whump of distant artillery. At around 150 yards from the pillbox, Japanese gunners shifted their attention. Machine gun rounds began pinging against the Sherman's frontal armor. The tank's hull shivered faintly with each impact. Tracers traced flat paths that terminated in tiny flashes against steel. To the men inside, those bullets were mostly noise. They could do little more than chip paint and damage periscope glass. Anti-tank guns were another matter, and everyone knew it. The driver kept the tank moving. Kissel watched the pressure gauge, its needle steady at 300 psi. He flicked his eyes to the small panel he'd wired for the ignition system. Everything in the green. The match cylinder, loaded with its ring of igniters, was ready. At about 100 yards, the driver stopped, then made a small pivot, slewing the hull to the left. The turret traverse motor whined as the commander brought the flame projector to bear on the pillbox's slit. In his periscope, Kissel saw the target line up. A horizontal rectangle downstairs in the landscape, just large enough to matter. He thumbed the trigger he'd wired. Up front, the solenoid he'd selected months before closed a high amperage circuit. The pump engage, D, hurling napalm through the lines. At the nozzle, the ignition cylinder rotated, its mechanism advancing a fresh match into the stream. An electrical impulse fired it. A jet of burning fuel erupted from the mantlet. From outside, anyone watching would have seen what the Marines later described simply as a sheet of fire. A lance of flame about a foot in diameter stabbed across the gap between the tank and the bunker, reaching the bunker's face in about 3 seconds. Then it blossomed, splashing against concrete and into the dark aperture. Napalm is not a Hollywood fireball. It is heavier than gasoline, viscous and adhesive. It sticks to whatever it hits, dripping and rolling into corners. Inside that pillbox, the Japanese machine gun crew had perhaps half a second to register the sudden roaring light before the embrasure became a mouth-vomiting fire. The burning mixture jetted through the slit and rolled along the ceiling and floor, flowing around the blast shields and into every recess. Oxygen vanished in an instant. Temperatures spiked into the thousands of degrees in the confined space. From the Sherman, Kissel saw smoke belch from every crack and vent in the bunker's face. He held the trigger for 5 seconds, counting it out in his head. 1, 2, 3, 4, 5. Roughly the entire combat life of a backpack flamethrower, poured in a single directed stream from under armor. Then he released. The flame cut off. Napalm still burned on and inside the position. The Type 92 fell silent and did not resume. Marines watching from shell scrapes and behind low rises stared for a moment, stunned. 2 days of nothing working. 2 days of dead men in front of that concrete tooth. Then, in all of 5 seconds, the thing was not just suppressed. It was dead. As smoke boiled out, a platoon leader on the line keyed his radio and spoke the new language of the battlefield. Pillbox destroyed. Send another flame tank. Back at the rally point, once the Sherman had reversed to relative safety, Kissel and Patterson went over, the CBH-1 like mechanics checking a race car after its first run. All systems nominal. No electrical shorts. No unexpected leaks. Fuel consumption within expected numbers. Ignition cylinder indexing properly. Pressure stable. The flame system had gone into combat once and worked exactly as it had in Hawaii. The difference was, this time, when the Marine slapped the side of the hull and grinned at the men inside, those smiles had casualties and pillboxes behind them. The suicidal weapon that Unmacht's composite unit had built. Suicidal in the sense that everyone involved had expected the tanks that carried it to become high-priority targets, had proven not just effective, but efficient. That afternoon, commanders who had held off calling for the Zippos suddenly wanted them everywhere. 3 more flame tanks went into action across different sectors of the island. Each time, they were fed targets that had resisted conventional attack. Tunnels with interlocking fields of fire, cave mouths that had survived direct hits from 75mm HE, pillboxes dug into the reverse slopes of ridges. It was not subtle work. A Zippo would trundle up under cover of smoke or supporting gunfire, halt within 50 to 150 yards of the target, and then bathe it in napalm. In many cases, Japanese defenders tried to hold their fire until the tank was very close, conserving ammunition and hoping to spring an anti-tank gun or satchel charge at the critical moment. Sometimes they succeeded, and flame tanks took hits like any other Sherman. A few Zippos on Iwo Jima were knocked out, burned or immobilized by mines and artillery. Being in one was never safe. But the missions on that first full day of combat use followed a pattern that would repeat itself. Each flame tank destroyed multiple positions. Each mission succeeded without losing a single Marine assaulting the target to sniper or machine gunfire. Instead of men with tanks on their backs running across open ground, vapors of fuel trailing them, bullets cracking past and into them, you had a steel box soaking up machine gun fire, while it delivered the same, or greater, volume of flame. By nightfall on February 21st, flame tanks were no longer a curiosity. They were in the battalion and regimental playbooks. The requests stacked up. Send flame tank to Ridge Sector X. Flame tank needed for caves near Hill Y. Zippo required at once for Strongpoint Z. Math was still a problem, just a different one. 8 tanks, 4 per Marine division on the island, 750 major Japanese fortifications, 11 miles of tunnel. The best men like Kissel could do was keep the ones they had running. That night, under intermittent artillery fire and in the fitful glow of distant burning positions, Kissel did the same work he'd done at Schofield, only now with grit, sweat, and occasional shrapnel in the mix. He pulled open access panels in tank hulls that had taken near misses. He checked wiring looms for insulation scuffed through by vibration. He tightened fittings on fuel lines that had seeped under the constant pounding. Patterson crawled underneath hulls to inspect welds, checking for hairline cracks where fuel tanks met structure. Tank crews, their nerves still more acclimated to regular gunnery than to removable fires, hovered nearby, handing tools and learning what they could. Electricians and shipfitters became, for a few weeks, as critical to the tempo of frontline operations as company commanders. Every morning, the same pattern repeated. Fresh targets, fresh requests. Flame tanks rolled out, did ugly, necessary work, rolled back in fume-reeking and blackened, then were patched and fueled again. There were close calls. On one mission near the northern plateau, a Zippo took a hit from a Japanese field gun that cracked an external fuel line. Napalm leaked onto the glacis, a slow, creeping flow. If a tracer had found it, the vehicle might have become exactly the kind of fireball its crews joked nervously about. Instead, a quick-thinking crewman hosed the front of his own tank with a CO2 extinguisher, while the driver backed them out of line of sight. Kissel climbed onto the still-warm hull with a wrench, grease gun, and a handful of clamps. He worked by touch more than sight, his fingers coated in sticky fuel, until the leak was stopped. On another day, a turret ignition system refused to cycle. The match wheel rotated once, then jammed. The operator hit the trigger and watched raw fuel stream out of the nozzle toward a cave mouth, unlit. It splashed and flowed, useless. Back at the rally, Kissel pulled the ignition cylinder, found a bent piece of internal linkage, and made an on-the-spot fix with a file and pliers. He and the crew tested it with a short burst against a rock face. The system worked again. For Marines who had watched too many friends die trying to do the same job with handheld flame, those little saves meant something. They began to see the Seabees electricians and welders not as rear echelon types, but as part of the same fight. And they began to treat the Zippos not as freaks, but as tools they depended on. From a distance, what the flame tanks did on Iwo Jima gets boiled down to a few statistics. 8 M4A3 R5 POA CWS H1. Zippos, each making dozens of sorties over the course of the campaign. Hundreds of caves, pillboxes, and spider holes cleared with flame where conventional weapons had failed. Thousands of Japanese soldiers killed or flushed into the open. Some post-war analyses estimated that flame tanks and other armored flamethrowers on Iwo probably accounted, directly or indirectly, for several thousand of the 21,000 plus Japanese dead on the island. More importantly, at least from a Marine infantryman's individual perspective, they saved thousands of Americans from having to make that last suicidal rush across open ash with tanks on their backs. Every pillbox burned by a Zippo was one less that would have required a half-dozen riflemen, a satchel charge team, and a flamethrower man to assault at grenade range. La Fière, it was not. There was no single 90-second sequence on Iwo where someone could point and say, "Here, this is where they saved the beachhead." Instead, it was a grim, methodical grind. Flame tanks would be called up to deal with hard targets, positions that had cost platoons casualties and hours of effort. They'd push to within range, loose controlled bursts that turned fortified holes into blast furnaces, then reverse under smoke. To the men in the tanks, it was hot, dangerous, monotonous work. To the Marines watching from the rocks and foxholes, it was magic. At a company of the 5th Marines pinned down by a Japanese strongpoint on the northern plateau, men reportedly cheered when a Zippo hove into view, its prow blackened, track links clattering. They'd watched it work on neighboring sectors. They knew what that projector could do in seconds. Kissel, who by this point had ridden inside on more than one mission and crawled over too many battered hulls to count, had a complicated reaction to all that cheering. He was proud, in the way any craftsman is proud when something he's built does the job it was meant to do. He was also keenly aware of the heat and smells that came back with every tank he touched. Burned fuel, scorched paint, something else sometimes, drifting faintly from the vents and seams of positions they'd just hit. Tank crews had their own coping mechanisms. Some joked about barbecues. Others got dead quiet after a run and didn't talk to anyone outside the crew for hours. Kissel kept working. He'd started this as a technical problem, a way to keep flamethrower men from dying at what felt like obscene rates. On Iwo Jima, the cost behind that problem was always visible. It was in the stretchers coming back from positions the flame tanks couldn't reach, from lines where there were no Zippos handy that day. It was in the body bags stacking up near the beachhead, and in the chaplains moving among rows of temporary crosses. U.S. casualties on Iwo would eventually total nearly 26,000, with over 6,800 killed in action. Without the flame tanks, that number could only have been higher. In after-action reports and post-war histories, the Zippos sometimes make only passing appearances, a paragraph here, a caption there. They weren't glamorous. They were tools. Commanders who had once been skeptical of chemical gadgets tended to forget their early reluctance and remember only that, when they needed a bunker burned, a particular call sign showed up and did it. Every now and then, though, you find a comment that captures what they meant on those blasted slopes. A Marine platoon leader on a ridge near Airfield No. 2, writing up his combat narrative, put it plainly. Without the flamethrower tanks, we would have had to take those positions with men carrying portable flamethrowers. I don't think we could have done it without losing half the company. An officer in the 4th Marine Division summarizing the campaign wrote, "The flame tank was our most effective single weapon against prepared positions." There's a straight line from that assessment back to Schofield Barracks and a handful of Seabees bent over wiring harnesses and weld seams. And there's a straight line from those shops to Joe Kissel sitting inside a Sherman on Iwo, listening to bullets ping on armor and counting out the seconds on a trigger. He was a Navy electrician. He was supposed to wire barracks and shipboard power circuits, not participate directly in armored assaults. But wars have a way of blurring lines when survival is on the line. Kissel went back to Hawaii after Iwo Jima. The flame tank program evolved. More tanks were modified for Okinawa and other operations. Designs changed. Capacities increased. After the war, as armored doctrine shifted and flamethrowers became politically and morally less acceptable, the Zippos slipped into the footnotes. He never thought of them as footnotes. Years later, if someone asked him about Iwo Jima, he didn't talk first about the size of the flame arcs or the number of electrical connections per hull. He talked about portable flamethrower men and their 92% casualty rates, about machine gun nests that ate men like a grinder, about walking into a tank that was, to the enemy, as obvious and hated a target as a man with fuel tanks on his back, only this time with a fighting chance. And he talked sometimes about the first time he fired the CBH-1 on a living target, how the gun that had killed 15 Marines fell silent in 5 seconds of controlled flame. Navy electricians don't usually end up in tank duels. On Iwo Jima, one did. He built a weapon everyone assumed would impose suicidal risks on the crews who used it, then climbed into it himself to make sure it worked. Behind him, on that February morning, were hundreds of Marines who would not have to cross those 200 yards of killing ground with tanks on their backs. In front of him, for a few seconds, was a concrete slit and the men behind it. Between the two stood a mass of steel, flame, and wire that a handful of Seabees had decided was worth their time, and, if necessary, their lives, to get right.